Hello everyone, I'm Paul and today we're solving problem 2094, finding 3-digit even numbers. There are at least two ways to solve this one, and in this video I will show you both, so keep watching. We're given an integer array digits, and this array may contain duplicate values, and we need to return a sorted array with integers we need to create. Now, to find valid integers, we need to meet these requirements. Each integer consists of the concatenation of 3 elements from digits in any order. The integer does not have leading zeros and the integer is even. So for example, let's say this is the original array, and from this we can create these 7 valid integers. So in this case we return this. Now here we have the constraints, and we know that digits length is smaller or equal to 100. This means we can solve this in big O of n cube. We can iterate this array with 3 pointers, I, j, and k, and each time we are checking if we meet these requirements, and if we do, we add the number to the result, and finally we sort this and we return it. Let's see how this works. The first integer we can create here is 228, and it's even, it doesn't have leading zeros, and it has 3 digits, so we can add it to the result. Next we update k and we have 228 again. We already have this in the result, so we update k again. The next number is 222, which is also even. It doesn't have leading zeros and it has 3 elements, so we can add this to our result. Next, j is here and k is here because we are starting from 0 every time. So 282 meets the requirements and it's not in the array, so we add here 282. The next number is 288. It meets the requirements and it's not in the array, so we add it. The next number is 282 and it meets the requirements. It's here, so we continue. Now j is here, k is here, and 282 is already here, so we continue. 288 is also here, so we continue. 282 is here, so we continue. Now I think you get the idea. This will continue and continue until we end the loop. So this will be the answer, and I know this might seem repetitive, but it is repetitive. It's hard work to process. That's why the complexity for this one is big O of n cube. And remember, later I will show you the efficient solution, but for now let's go with the code for this one. First, n equals length of digits, result equals an empty array. We will create a set to store values, and for I in range n, remember we are starting from 0 each time, so for j in range n and for k in range n, if I equals j or j equals k or I equals k, we want to continue because we need the indexes to be different. And now the current integer will be digits I plus digits j plus digits k, and we want to convert each of these into a string like this. And now if the first digit car at 0 is different from 0 and the current modded by 2 is 0, and not car in scene is if this is the first time we see this digit. In this case, we can add to the set current, and we can add to the result current converted to an integer. And finally we can sort this because we need to return the result in sorted order, and finally we return the result. So this is the entire code, and now we'll submit this and see if it works. Here I'm missing a parenthesis, so let's fix this and try again. And as you can see, this works, but it's not very efficient, so now we will go with the efficient solution. Now let's look at the requirements. We know that the valid integers will always have 3 elements. This means we can iterate every number from 100 up to 999, okay, so every number with 3 digits, and check if we can build them with the original array we have. So for example, let's say once again we have this array, and now we are iterating every number from 100 up to 999 to check which number is valid, and each time we find the valid number we are adding that to our result. So let's say we are currently at number 222, and we are checking if we have 3 choose in our original array to build this and add this to the result. So here we have 1, 2, 3 choose. This means we can build this, so we add it to our result. And now we want to repeat this same process with every other number, and if we have enough elements in the original array to build that number and the number is even, we can add it to the result. We don't have to worry about leading zeros anymore because we are iterating from 100 up to 999. So now let's go with the code, and hopefully you'll get the idea. First we want to create a frequency map for digits, so map equals default dictionary, and we will set a default value of 0 for every key like this, and for every digit in digits map at the digit plus equal 1, and initially result is an empty array. And now for I in range from 100 up to 1000, now we want to pre-process the number we are working with. So let's say we are working with 100. We want to know which is the first digit, the second one, the third one, and we will store that into a temporary frequency map. And then we are checking if we have enough digits in our original frequency map, and if we do, we are adding the number to our result. So the first digit is I multiplied by 10, the second digit is I divided by 10 and multiplied by 10, and the third digit equals I divided by 100 multiplied by 10. Now we want to create a temporary frequency map to store these digits, so temp equals default dictionary with a default of 0 also, and temporary at A plus equal 1, temporary at B plus equal 1, temporary at C plus equal 1. And now if temporary at A is smaller or equal to map at A, and temporary at B is smaller or equal to map at B, and temporary at C is smaller or equal to map at C, and if I multiplied by 2 equals 0, so if the number is even, in this case we add to our result the current integer, and finally we return the result. So this is the entire code, and now we'll submit this and see if it works. And as you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.